Welcome to Elevate Learn. In this tutorial, you'll master Python packaging and publishing, one of the most valuable skills for any developer. Whether you're building a utility library, a data science tool, or a web framework, knowing how to package and publish your code to PyPI opens doors to collaboration and recognition. By the end of this tutorial, you'll understand the entire workflow from structuring your project to sharing it with millions of developers worldwide. Let's elevate your Python skills. Here's your roadmap for today's learning journey. We'll start by exploring what PyPI is and why it's crucial for Python developers. Then we'll dive into organizing your project with proper directory structures that follow Python conventions. You'll learn to write setup.py and modern PyProject.toml configurations that tell pip how to install your package. We'll build both wheel and source distributions, understand the difference, and master the authentication process for uploading to PyPI. Finally, we'll verify everything works, discuss versioning strategies, and cover common problems you might encounter. By the end, you'll be confident in publishing professional Python packages. PyPI, the Python Package Index, is the central hub where over 500,000 Python packages live. When you type pip install requests or pip install numpy, pip downloads those packages from PyPI. By packaging your code, you're making it installable with a single command. No manual downloading or setup required. This democratizes access to your work. Professional packaging includes metadata like author information, dependencies, and version numbers. It ensures users get exactly the right version of your code, with all its requirements automatically installed. Whether you're building a utility for data scientists, a web framework, or a specialized algorithm library, packaging is how you share it with the world. The Python community thrives on this ecosystem, and learning to package properly is a mark of professional development. Project structure matters because it's the first thing PyPI sees. The industry standard layout uses a src/directory containing your actual package, separate from tests and documentation. This structure prevents accidental imports of the development version. Your project root should contain a README that explains what your package does. This becomes your PyPI homepage. Include a license file because open source without a license creates legal ambiguity. Create a manifest.in to specify which files to include beyond Python source code, like data files or examples. Keep tests separate in a test/directory, organized the same way as your package. The setup.py file declares your package's metadata: name, version, author, dependencies, and entry points. Modern projects use PyProject.toml for configuration, which is more flexible and follows Python's evolution towards standards-based packaging. When you publish a package, PyPI stores two types of files. A source distribution is essentially a zip of your source code. Users must compile or build it during installation, which takes time and can fail if dependencies are missing. A wheel is different. It's a pre-built archive that pip simply extracts and installs, making installation nearly instant. For pure Python packages, wheels work across Python versions and operating systems. For packages with compiled C extensions, you'd create platform-specific wheels for each OS. The beauty of modern packaging tools is they handle wheel creation automatically. You don't write custom build scripts, setup tools, and the build module do it for you. Always publish both wheel and source distributions so users have options, but wheels are what makes modern Python fast and reliable. This is a modern PyProject.toml file, the heart of your package configuration. The build system section tells pip how to build your package using setup tools and wheel. The project section contains metadata: your package name, version, description, and Python version requirements. Setting requires Python ensures users with incompatible Python versions get a clear error. Dependencies go in the main requirements list, while optional development dependencies go in the dev section. Authors and keywords help users find your package. Classifiers tag your project for PyPI search and categorization. The setup tools section specifies which directories contain your code. This configuration is standard across the Python community and is what PyPI expects to see. When you create a properly formatted PyProject.toml, pip and build tools validate its structure. The output confirms your project is configured correctly. The build system is properly set up to use setup tools. Your project metadata is complete with name, version, and Python version constraints. PyPI will read this metadata to display your package information. Users can install optional development dependencies using the bracket syntax. This validation happens automatically when you try to build or install your package. A successful validation means you're ready for the next step, actually building distributions. The setup.py file is a Python script that defines your package configuration. The setup function receives all metadata and build instructions. Using find_packages, automatically discovers all your package directories. The package_dir parameter tells setup tools where to find your source code. Using src/ is a best practice. Reading readme.md dynamically means PyPI gets your full documentation. Entry points are powerful. They let you create command line commands from your package functions. For example, this config creates a calc command that runs the main function from your CLI module. When users install your package, typing calc in their terminal runs your code. This is how tools like pip, black, and pytest provide command line interfaces. The install_requires list specifies runtime dependencies. These are installed automatically when users install your package. When setup tools processes your setup.py, it reads all the metadata and validates it against PyPI standards. It discovers all packages in your src/directory using find_packages. The long underscore description from your README is incorporated into the package metadata. This is what PyPI displays as your package homepage. Requires .txt captures your dependencies. Entry points are written to a special file that pip uses to create command line scripts. All this information is collected into eginfo metadata that pip reads during installation. This validation step is crucial. It catches configuration errors early before you upload to PyPI. Once validation succeeds, you're ready to build actual distributions. The build module is the modern, recommended way to create distributions. Instead of running setup tools directly, you run Python mbuild, which orchestrates the entire build process. This creates two distribution files in the dist/directory, a source distribution and a wheel. The source distribution contains your raw source code. Users can inspect and modify it if needed. The wheel is pre-built and optimized for quick installation. For pure Python packages, a single wheel works across all platforms and Python versions. The file names encode important information: the package name, version, and target Python versions. When you upload these to PyPI, users can install from either file. Wheels are preferred because they're instant, but having the source available is important for transparency and debugging. The build process creates an isolated environment to ensure clean, reproducible builds. This prevents your local development setup from affecting the final package. Both a source distribution and wheel are built. The PY3, none, any designation means the wheel is compatible with Python 3, any platform, none means no OS restriction, and any CPU architecture. These files are ready to upload to PyPI. The sizes shown are typical for simple packages. Larger packages with dependencies might be bigger. You now have distributable artifacts that anyone can install with pip. This is the moment where your local code becomes a globally distributable package. Twine is the secure, recommended way to upload packages to PyPI. It encrypts your credentials and uses HTTPS to transmit your packages. Before uploading, always run Twine check to validate your package metadata. This catches issues like malformed README formatting or missing required fields. Create a PyPI account at pypi.org and generate an API token in your settings. This token is more secure than using your password. When you run Twine upload, it reads the distributions from your dist/folder and uploads them securely. Twine prompts for your username and password. Enter __token __ as username and your token as password. The validation and upload process completes in seconds. PyPI receives both your wheel and source distribution and validates them against official standards. Your metadata is parsed and displayed on your PyPI project page. Users can immediately search for and install your package. The URL shown is where your package lives on PyPI. Users visit this to see your description, installation instructions, and version history. Your first release is now live. This is a significant moment. Your code is now part of the global Python ecosystem, available to anyone with pip. The package page shows your README, classifiers, version history, download statistics, and more. Every time someone installs your package, PyPI tracks it. You've successfully published your first Python package. Testing your published package in a fresh environment ensures it works for real users. Create a new virtual environment to isolate the test. This prevents your development setup from interfering. Install your package using pip, just as users would. PyPI serves the wheel file, which downloads and installs instantly. Test basic functionality with Python imports and function calls. If you created command line entry points, test those too. The pip show command displays all metadata about your installed package, matching what users see on PyPI. This real-world test validates that all dependencies are correct, all files are included, and installation is smooth. If something fails here, you catch it before users encounter problems. This is professional development, ensuring your users have a great first experience. Packaging mistakes can embarrass you and frustrate users. Never upload without proper version numbers. PyPI requires them and users depend on semantic versioning to understand compatibility. Your code should use relative imports, not absolute paths based on your machine's directory structure. Always include a README describing your package and a license stating the usage terms. Take time to write meaningful docstrings and setup.py metadata. This is what users read. Never commit secrets to your repository. API keys, passwords, and tokens leak and create security vulnerabilities. Use environment variables and .gitignore to protect sensitive data. Test your package in a clean environment before uploading. Avoid uploading multiple versions per day or uploading broken code. These practices seem obvious in retrospect but are easy to overlook when excited to publish. Taking care with these details demonstrates professionalism. This is an important distinction that affects user experience. Wheels are optimized for installation. Pip simply extracts and copies files, making installation nearly instant. For pure Python packages, a single wheel works across all platforms. Source distributions preserve everything: raw code, tests, and documentation. Users can inspect and modify source, which is important for transparency. However, building from source takes time and can fail if dependencies are missing. PyPI and pip evolved toward wheels because they're more reliable. Modern best practice is to always upload both formats. Users who need the source for inspection or modification can download it. Most users get the speed benefit of wheels. This dual release approach serves everyone well. Understanding where to declare dependencies is crucial for package configuration. Runtime dependencies, what users need to run your code, go in the install_requires list. These are installed automatically when users install your package. Development dependencies like testing tools and linters go in optional dependencies sections. Users can install them with pip install mypackage dev. The requires Python field specifies minimum Python versions. This prevents users with Python 3.7 from installing packages that require Python 3.10. Properly declaring dependencies makes your package easier to install and maintain. Missing dependencies cause mysterious import errors for users. Over-declaring dependencies makes your package heavier and creates compatibility conflicts. Getting this right matters. Before uploading to PyPI, always run twine check. This command validates everything about your package that PyPI will process. It parses your README and checks that it renders correctly on PyPI. Restructured text and markdown formatting errors are caught here. All required metadata fields like name, version, and description are verified to exist and be properly formatted. Classifier values are checked against the official PyPI taxonomy. Your long underscore description is validated. Running twine check prevents embarrassing situations where your package appears on PyPI with a broken README or missing information. It's a small, free validation step that catches almost all common mistakes. Professional developers run this automatically before every upload. Make it a habit. You've learned the complete workflow for packaging and publishing Python packages. PyPI is where the Python community discovers and installs code. Proper packaging is your entry ticket. Start with standard project structure. src/ contains your code, test/ holds your tests, and root files document everything. Write comprehensive setup.py or pyproject.toml with all metadata and dependencies. Use the build module to create both wheel and source distributions. Run twine check to validate before uploading. Use twine upload to publish securely. Always test in a clean environment to verify users can install and use your package. Follow semantic versioning so users understand compatibility. Protect secrets with environment variables and .gitignore. These practices transform your personal project into a professional package that users trust. Every successful upload adds your code to the global Python ecosystem. This is how legendary libraries like NumPy, Django, and Request started, with developers like you learning to package properly. You're now equipped to share your creations with the world.